Hey, Cricket customers, Max with ads is included with your Cricket $60 unlimited plan at no additional cost.
Nice!
Max is the streaming platform where you can watch Scoob, Meg 2 The Trench, The Nightmare on Elm Street collection, and so much more.
Remember me.
Just log in with your Cricket username and password to experience Max on all your favorite devices.
We've never seen this before.
Max, the one to watch for a good scream with Cricket. Phone plan streams in standard definition. Programming subject to change. Fees, terms, and restrictions apply. See cricketwireless.com for details.
If you're getting ready to do your holiday shopping at Sephora, Nike, or Neiman Marcus, make sure you head to Rakuten first. Rakuten helps you save big on whatever you're buying for the holidays. Getting gifts for friends and family? Get some cash back for yourself. Plus, save on festive home decor, party outfits, and that trip to see your fam. With Rakuten, you can earn cash back on top of the biggest sales of the season, so you get the most savings. And it's easy to use. Just start your shopping at Rakuten.com or use the Rakuten app, and you'll get your cash back payments through PayPal or check. Rakuten partners with over 3,700 stores. The stores pay Rakuten for sending them shoppers, and Rakuten shares the money with you as cash back. Join for free at Rakuten.com and get the Rakuten app. That's RAKUTEN.
This is SpaceTime Series 26, Episode 24, for broadcast on the 24th of February 2023. Coming up on SpaceTime, a study of the complex Martian subsurface, astronomers angry over commercial satellite pollution, and China busy with spy satellites and balloons. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Ground-penetrating radar from China's Martian rover Zhurong has revealed shallow impact craters and other geological structures in the top 5 meters of the red planet's surface. Zhurong was launched back in July 2020, landing on the red planet's Utopia Planitia region in May 2021. Utopia Planitia is a large plain in the Martian Northern Hemisphere, near the boundary between the Martian Northern Lowlands and the Southern Highlands. The region was chosen because it's near the suspected ancient shoreline of what was once a vast Northern Hemisphere ocean. The tiny rover's primary mission was to search for evidence of water or ice. Large reserves of underground ice were identified in a nearby part of Utopia Planitia back in 2016. That was by radar observations taken by NASA's Mars Reconnaissance Orbiter. After landing, Zhurong travelled about 1.9 kilometres south, taking images of rocks, sand dunes and impact craters along the way, and also collecting data from ground-penetrating radar. Ground-penetrating radar detects features underground by sending electromagnetic pulses into the ground, which are then reflected back by any subsurface structures it passes over. Zhurong uses 2 radar frequencies, a low frequency which reaches down to around 80 metres but with less detail, and a higher frequency which was used for this latest study which shows more detailed features but only reaches down about 4.5 metres. Researchers hope that by imaging the subsurface of Mars, they'll shed more light on the red planet's geologic history, its previous climatic conditions, and any water or ice the planet may host now or in the past. The findings, reported in the journal Geology, show evidence of several curving and dipping underground structures in the Martian soil that appear to be buried impact craters, as well as other sloping features with less certain origins. Importantly, there was no evidence of water or ice, at least not in the top 5 metres of soil. Radar images of deeper structures did reveal layers of sediment left by episodes of flooding and deposition in the past, but also found no evidence of water in the present day. Now, this doesn't rule out the possibility of there being water deeper than the 80 metres imaged with the radar, but it does set some constraints as to what's accessible. The study contrasts the data from Mars with ground-penetrating radar previously collected from the Earth's moon, which shows a very different shallow subsurface structure. Where the shallow Martian surface contains several distinct features that show up in the radar, the top 10 metres of the Moon has fine layers but no evidence of other structures like impact crater walls, despite also being subjected to meteorite bombardment. The walls of impact craters are, however, observed at greater depths on the Moon, buried deep beneath the 10-metre thick layer of fine debris. The difference could be the atmosphere. While Mars has an atmosphere only 1% as thick as the Earth's atmosphere, that's still a lot more than the Moon, which has virtually no atmosphere at all. So with essentially no atmospheric protection, the Moon's surface is constantly bombarded by even the smallest micrometeorites. And over billions of years they've reworked the surface, eroding small-scale features and leaving behind lots and lots of fine layers of ejecta. By contrast, the surface of Mars is not being subjected to nearly as many micrometeorite impacts. That's because these smaller objects burn up in the atmosphere. In the regions imaged by Xeron, burial by wind-blown sediments may also have protected the impact craters from erosion. One of the craters imaged had its rim exposed to the surface, but the other crater was totally buried. Whether we'll get more information from Xeron is debatable. China recently lost contact with the rover and has been unable to re-establish communications. Xeron, which is named after a Chinese god of fire, was placed into hibernation mode more than 6 months ago in order to deal with the freezing Martian winter, where temperatures commonly tip below minus 100 degrees Celsius. And the area also experienced a severe regional dust storm, which may have covered the rover's solar panels with lots of dirt, preventing it from gathering power to charge its batteries. Xeron's mission, therefore, may be over. This is SpaceTime. Still to come, astronomers angry over the growing levels of commercial satellite pollution, and China caught out playing with spy satellites and balloons. All that and more still to come on SpaceTime.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.
There's growing concern in the scientific community about the number of commercial satellites now being launched into orbit, many of which are reflecting so much light they're destroying important astronomical research. It's now commonplace for major scientific projects to be disrupted by trains of satellites streaking across the skies. The International Astronomical Union has formally warned that some of these spacecraft, such as the massive Blue Walker 3 telecommunications satellite, are every bit as bright as first-magnitude stars, which puts them on par with some of the brightest stars in the sky. The 1.5-ton Blue Walker 3 spacecraft employs a massive 64-square-metre solar array, and it's designed to communicate directly with cellular devices through 3GPP standard frequencies at 5G speeds. Orbiting at an altitude of 515 kilometres, Blue Walker 3 is being controlled by a network of 3 tracking stations in Maryland, Colorado and Australia. The satellite has a field of view covering more than 777,000 square kilometres of the surface of the Earth. It's currently the largest commercial telecommunications satellite in low Earth orbit, and the company is planning to launch 6 of these satellites every month, building up to an eventual constellation of over 100 spacecraft. And it's not just the visible brightness that astronomers are finding concerning. Blue Walker 3 also emits strong radio waves that are also interfering with the work of astronomers. Philip Diamond, the Director General of the Square Kilometre Array Observatory, says the reason radio telescopes are situated in radio-quiet areas, far away from the electronic noise of civilization, and in regions specially designated through legislation as radio-quiet zones with no cell phone or radio coverage, is to avoid the electromagnetic pollution which can compromise an astronomer's ability to do science. He says the frequencies allocated to cell phones are already challenging astronomers to observe even in radio-quiet zones created for these observations. And Blue Walker 3 isn't alone. SpaceX's Starlink now have almost 4,000 broadband satellites in 72 orbital planes at altitudes of around 550 kilometres. And there are plans for an eventual constellation of around 42,000 of these satellites. And while the first generation Starlink satellites are small, just 260, 306 kilograms in mass, the larger Phase 2 versions will be well over 1.25 tons each. And Starlink isn't alone either. OneWeb are about to complete their initial constellation of 648 satellites, with proposals to increase that to 6,372 spacecraft under Phase 2 plans. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says new satellites such as Blue Walker 3, Starlink and OneWeb have the potential to seriously worsen the situation, if not properly mitigated.
It's becoming a bit of a problem, actually, because, when you look up, go back decades, you look up in the night sky and you'd be lucky to see a satellite. You could only see them at certain times of the day or night, usually just after sunset. Or just before dawn when the angle was right, so they were catching the light. And decades ago, there weren't that many satellites, really, compared to today. I mean, I remember back in the 80s, there were proposals, some people, were going to put up huge billboards in space, like big glowing signs, to advertise certain cola-flavoured drinks or something. And people were really worried about this, advertising in space, for goodness sake, they'd have some big billboard floating overhead. Fortunately, those things didn't come to fruition. But the problem we have now is that there's this proliferation of tiny, tiny, tiny satellites that are they're amazing satellites, and they're mainly used for communications. They're these big sort of communications networks. So like Elon Musk's Starlink, brilliant service that it can provide. You can communicate from basically anywhere on the planet with a fairly inexpensive handset. But the problem for astronomers here is that these things do catch the light. So as you say, if you're taking a picture of a distant quasar or something, and all of a sudden the satellite goes right through the middle of it with this shining this light, reflecting this light down into your telescope, it's ruined it. And there are plans to have tens of thousands of these things up there.
Well, Starlink's now got, 3,666 as of last count.
Yeah, well, I think he's got approval, 44,000 or something, something like that. And look, and he's not the only one. There are plenty of others who want to do it as well. And there's an estimated, perhaps 100,000 of these things will be up there soon. So it will mean that the one we're talking about in the magazine is called Blue Walker, and these are small satellites. The main guts of the satellite is small, but it's got a large solar panel array, which is fantastic for reflecting sunlight, and because it's designed to look at the panels are designed to point at the sun. And if you get the right angles, of course, then this causes a big flash in the night sky or a big moving dot of light in the night sky. And with potentially 100,000 of these things up there, it's going to ruin, or at least affect, every single picture that you would take of anything in the night sky, essentially. There'd be no way around it. The only way to, if these satellite operators can't figure out a way to change their satellites to make them less reflective or something, or angle them in a different way, then astronomers are going to be out of a job. They'll have to rely on just space observatories up there. And some people have suggested, well, this might be the reason why we have to move observatories to the moon.
The idea of building originally radio telescopes, but, why not optical telescopes on the far side of the moon?
Radio telescopes on the far side of the moon would be brilliant, because the bulk of the moon would block any interference from the Earth, but you could stick an optical sort of telescope anywhere, really. Far side would be fantastic. And the thing is, pretty much like telescopes these days, it'd be automated. You wouldn't have astronauts up there running them. You just get them set up and then just let them do their thing. So that may happen. The other big problem with the proliferation of all these little satellites is a thing called the Kessler syndrome. Now, this was named after a person called Kessler, of course, who raised the prospect of a potential big problem, which is where if you've got hundreds of thousands of satellites up there, even with the best of intentions, some of them are going to run into each other. And when you get two satellites smash into each other at high velocity, it's going to cause a huge debris field. And every little bit of those debris can race off in different directions and then smash into other satellites, which then break up and then smash into other satellites. And before you know it, you've got a chain reaction happening where all these satellites are obliterating each other up there in space. And you end up with a huge swarm of just space junk floating around the planet. So bad that it would be perilous to launch anything through that swarm, right, to get to other orbits, whether it's unmanned or manned craft. It is a real potentiality, that would just basically stop spaceflight or any sort of space exploration or the launching of new or replacement communication satellites and Earth observation satellites, all these things we rely upon, GPS satellites. It would basically mean that we would be stopped from launching them for decades. Unless we wanted to run the risk of every third one getting destroyed, or 2 out of 3 getting destroyed on their way up. We'd have to send up lots of them and hope to get some get through. So that's another big problem, or potential problem as well.
It's provided a great opportunity for a company called Leo Labs to develop their your own satellite control system, a traffic control system for satellites. So you know where your satellites are and where potential dangers threaten so you can avoid them.
So you can avoid them, yeah, but it's all very well, but what if one malfunctions and you lose control of it? So,
well, then you get a Hollywood movie made. The one good thing the movie Gravity did was it showed us what the Kessler syndrome was like.
Correct. That's exactly right. Yeah,
that was brilliantly portrayed in that movie. I mean, the idea of jumping from one spacecraft to another, that's not going to happen. But
look, there's the space station just over there. Yeah. They took some understandable license, I guess, with the laws of physics to make the story work.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come, China launching more and more spy satellites and now spy balloons. And later in the science report, researchers suggest that it only took 10,000 years to populate all of Australia and Papua New Guinea. All that and more still to come on SpaceTime. It's been a busy start to 2023 for China, with multiple rocket launches, many carrying military spy satellites, as Beijing continues what Chinese President Xi Jinping and his communist government describe as preparations for war. On January the 13th, a Long March 2D rocket carrying the Yaogan 37 and Cheyenne 22A and B satellites launched from the Zhuquan Satellite Launch Center in the Gobi Desert. The United States Space Force's 18th Space Defense Squadron says the three spacecraft were placed into a 515-kilometer high circular orbit. China's state-run media claims the three satellites will be mainly used for in-orbit verification of new technologies, such as space environment monitoring and remote sensing. The Xianyang designation is used for experimental spacecraft programs. However, the Yaogan 37 is nothing more than a classified military surveillance satellite operated by the People's Liberation Army to spy on other nations. Meanwhile, a week earlier, back on January the 8th, China's first launch for 2023 was a Long March 7A rocket from the Wenchang Space Launch Center in Henan Province, carrying 3 satellites into orbit. And this is where the story gets rather confusing. The official Chinese news agency claims the mission carried the Shenzhen 23 and Cheyenne 22A and 22B experimental satellites. Now, the thing is, they're the same Cheyenne 22A and B satellites that were supposed to have launched 5 days later from Zhuquan. So that means there's obviously something else being launched that they don't want you to know about. And the third spacecraft aboard the flight, the Shenzhen 23, is also interesting. It was observed deploying a smaller satellite once in orbit. The US Space Force thinks the smaller satellite may have been a payload attached to an AKM, that is apogee kick motor, but determining any more than that would be guesswork. The orbital deployment occurred in geostationary space at an altitude of 35,786 kilometers. A similar operation occurred 2 years ago with the Shenzhen 21 spacecraft. It deployed a small satellite which was then used for testing. The Shenzhen 21 then docked with the disused Bedao 2G2 Chinese navigation satellite and physically moved it into a new different orbit, proving that China now has the technology to grab and manipulate the spacecraft of other nations. That means you could either knock it out of orbit or add something else to it. Just 13 hours before the Zhuquan launch, Beijing launched a Long March 2C rocket from the Xichang Satellite Launch Center in southwestern China's Sichuan province, carrying the S26E telecommunications satellite into geostationary orbit. The 4.3-ton satellite carries 25 Ku band and 3 Ka band gateway transponders. It'll be used to provide high-throughput broadband telecommunications services on a footprint covering Southeast Asia. Then on January the 15th, China launched a Long March 2D rocket from the Taiyuan Satellite Launch Center in northern China's Jiangxi province, carrying 14 satellites into orbit. The payloads included a mixture of remote sensing and optical high-resolution surveillance satellites. A week earlier, Galactic Energy launched its 5th Series 1 rocket from Zhaiquan, carrying 5 small satellites into orbit. The successful mission brings to 19 the number of satellites placed in orbit by Galactic Energy. The 20-metre-tall Series 1 launch vehicle can place payloads of up to 300 kilograms into 500-kilometre high sun-synchronous orbits. China now has an estimated 611 satellites orbiting the Earth, including more than 259 Earth observation, surveillance and reconnaissance satellites, and they include at least 47 Gaofeng and 112 Yaogang spy satellites. China has announced plans to carry out at least 60 orbital missions this year. And of course, it's not just satellites. On February the 4th, a US Air Force F-22 Raptor shot down a high-altitude Chinese spy balloon, which had been flying over at least half a dozen classified American nuclear facilities. Beijing claimed it was just a rogue weather balloon that had veered off course. Yet its flight path just coincidentally happened to take it over several intercontinental ballistic missile launch silos and a number of US Air Force bases. Former US Joint Chiefs of Staff Chairman Mike Mullen rejected China's claims that it was simply blown off course, saying the balloon had propellers and was maneuverable, able to change its course and altitude at will. The Pentagon says the 60-metre tall balloon flew at an altitude of 55,000 feet or 17 kilometres at an average speed of 25 knots or 46 kilometres per hour. It was carrying an extensive solar array and several tons of surveillance and reconnaissance equipment designed to intercept signals and communications and then beam that data by satellite back to Beijing. The Pentagon says steps were taken to prevent the balloon's instruments from collecting confidential information during its flight. It says it monitored the balloon being launched from China's Henan Island, flying towards the US military base on Guam, but then suddenly veering northeast and entering US airspace over Alaska's Aleutian Islands on January the 28th. It then flew over mainland Alaska and Canada before suddenly heading south and re-entering the continental United States airspace over northern Idaho on January the 31st. The next day it was spotted over Montana's Minuteman III missile silos before heading towards the Ellsworth Air Force Base in South Dakota, where the US Air Force's new B-21 stealth bombers are being based. The balloon was finally ordered shot down above the Atlantic Ocean off the coast of South Carolina, falling into relatively shallow waters just 14 meters deep, where it was retrieved by the US Coast Guard and Navy. Beijing later acknowledged a second balloon, another weather balloon, had run off course. This one was spotted by US and Colombian officials as it drifted over Latin America. And that's raising questions as to how many of these balloons are being launched by China and over which countries. Throughout this saga, US President Joe Biden has been heavily criticised over his failure to act earlier when the balloon first appeared in US airspace. He was then criticised for his overcompensation by ordering the military to shoot down 3 further smaller balloons without identifying what they were. We know one was the size of a car that was shot down over Alaska. A second one, sort of lozenge-shaped, was shot down over Canada's Yukon Territory by US fighters, not by the Royal Canadian Air Force. And a third hexagonal object took 2 missiles to shoot down over Lake Huron. After initially trying to avoid the issue, Biden was later forced to confirm that none of these 3 objects were spy balloons, but rather legitimate civilian weather and scientific balloons. In an attempt to deflect criticism from Biden's failure to act earlier, the White House claimed 3 similar events had occurred during the Trump presidency. However, that was quickly rejected by General Glenn Van Heck, the commander of the North American Aerospace Defense Command NORAD, who said no such events had ever been detected. The White House were then asked if aliens from outer space could have been involved, from which point the whole thing's degraded into a bit of a farce. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that around 1 in 6 Australians over the age of 14 are still using tobacco and cannabis, or both, despite their known carcinogenic and mental health effects, respectively. The findings, reported in the Australian Drug and Alcohol Review, are based on a study of over 20,000 people. It shows that 1 in 10 smoke tobacco, while nearly 1 in 12 use cannabis. The authors looked at the rates of cannabis and tobacco use over the past 12 months, and they searched for patterns to the type of people who use them. They say 2.4% of respondents use both tobacco and cannabis, 5.5% use cannabis alone, 8% use tobacco alone, and 84% of people use neither. A small Australian trial has shown that adding a type of high-fibre supplement to people's diets helped reduce their blood pressure by changing their gut bacteria. The findings, reported in the journal Nature Cardiovascular Research, included 20 people who were given food for 3 weeks that either contained a high-fibre supplement, a resistant starch called hamshab, or a placebo. The group who ate the diet with the resistant starch had a clinically significant drop in their systolic blood pressure. The hamshab diet also changed people's gut bacteria, and these changes are likely to be what's helped to lower their blood pressure. The authors say the drop in blood pressure is equivalent to taking blood pressure-lowering drugs and could reduce coronary death by 9% and stroke death by 14%. New research has revealed that it took about 10,000 years to fully populate the entire continent of Saul. Saul is the name of the combined megacontinent that joined Australia with New Guinea when sea levels were much lower than today. The findings, reported in the journal Quarterly Science Reviews, are based on sophisticated new computer simulations combining improvements in demography and models showing geographic influences in order to show the scale of challenges faced by the ancestors of indigenous people as they made their mass migration across the supercontinent more than 60,000 years ago. The pattern led to a rapid expansion both southward towards the Great Australian Bight and northward from the Kimberley region to settle all parts of New Guinea and later the southwest and southeast of Australia. As the world transitions away from fossil fuels such as coal-fired power stations, the so-called greener alternatives of renewable energy from solar and wind are showing that they have their own serious problems. Renewables mean blackouts when the sun doesn't shine and the wind doesn't blow. It also means bird populations being slaughtered by wind turbines and mining pollution poisoning vast areas of land in order to obtain the rare earths needed for solar panels and batteries. The CSIRO says the cost of new poles and wires in Eastern Australia alone will be more than $1 trillion. Guess who's paying for that? Building gas turbines or modular nuclear power plants next to existing power stations would be an economical solution, but politically undesirable. So, the recent breakthrough in laser nuclear fusion research by the Lawrence Livermore National Laboratories has been widely welcomed and celebrated. Scientists fired an array of ultra-high-powered lasers at a tiny tritium-deuterium pellet, triggering nuclear fusion. What made this event different is that they generated more power than what it took to trigger the event in the first place, in the process replicating the forces that power the sun. It's a small but highly significant step on the ladder to produce pollution-free limitless energy, and without all the radioactive waste associated with today's nuclear fusion power stations. But there's a big difference between doing it for a split second in the lab and being able to replicate that on an industrial scale, generating enough reliable electricity to power a city. And so that's triggered a good degree of skepticism, despite the important proof of concept advances that it's achieved. Tim Mendham from Australian Skeptics says there have been lots of promises before about nuclear fusion, and a commercial supply is still decades away.
The trouble is with the history of nuclear fusion energy has been full of ups and downs and missteps and hoaxes and misunderstandings and all sorts of things, which make people wonder, will we ever get there? Obviously, the idea is that to get there is the power, it's the activity that powers the sun, and if we can have it, we do without all waste. It's an easily accessible source of
warming would end.
Global warming would end. Reliance on fossil fuels would end. I don't know if global warming would completely end. It would certainly end a lot. The idea is that, therefore, you can get unlimited energy from a source that is really basically water, and you use that for fusing hydrogen. But people have been trying to do this for 100 years, ever since people started looking at the makeup of atoms, etc., say with atomic physics and that sort of thing. And they've had very poor success, actually, obviously, along the road here. Some good ideas, some bad ideas. It's been tried out by Europeans, Americans, Russians, all sorts of different people.
There were some very badly designed experiments as well, like cold fusion.
Yeah, cold fusion with the Ponce and Fleischmann, the two American researchers who had this great claim that was totally overhyped, but it was picked up by a lot of magazines, science, probably sober science publications and that sort of thing, as an amazing breakthrough, and it turned out that it was totally, I wouldn't say a hoax, it was just an error, a mistake, just an over-enthusiastic response.
Badly designed experiment.
Yeah, but there are others. There's a fellow in Italy who has supposedly possibly developed a desktop fusion reactor, which would be interesting, seeing as fusion reactors tend to be rather large. This is basically you plug it in and you can create fusion energy. He's been touting this around all over the place, trying to get people to buy licenses, to get investors, to get all sorts of things, and there really is no evidence. We skeptics here, we investigated it and had a look at it, had a look at the wiring, etc., and we found there's probably sort of some rather hidden wiring involving power in, power out, using the Earth connection or whatever, that it's not quite what it appears to be, and it sort of fooled a lot of people. The followers of the history of nuclear fusion probably following it very closely, and they have very jaundiced view about a lot of these people. So it's not skepticism of nuclear fusion per se, but it's skepticism and cynicism of the history of it so far.
Yeah.
Yeah.
Well, the thing is, even with this Lawrence Livermore experiment, which was a success, it was a once-off thing. They needed so much energy to carry out this fusion event. It's not something they can do continuously.
It's not something you couldn't have tapped your power system into it, because it lasted how long?
A gazillionth of a second, I think.
A gazillionth of a second,
that's a scientific term.
Yes, a gazillionth of a second, and it's sort of not something you can actually sort of practically apply at this stage. They're just showing that it works. It's not something you can actually use at this stage. So the theory is they want to get the practical proof of it, and they're heading that way. Probably eventually we would think they would, but how far down the track that is.
Well, I've been reporting on this for the last 30 years of my time as a reporter and a journalist and a broadcaster, and I can tell you that it's always been about 20 years away.
Oh,
that was 30 years ago, and it's 20 years away 10 years ago, and it's 20 years away now.
Yeah, and it's the improvements are tiny incremental improvements, right? But this one is interesting because they are getting more energy out than put in, but you got to continue it. You got to have the right technology. As you say, it has to be repeatable, and that's the hard thing. So maybe they've cracked it, but it's going to be a long time before it becomes anything usable.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.